Ancestral protein reconstruction is a methodology used to determine the phenotypical evolution of a protein. This is done in reverse from where we are today to the past, so ignore the order the images are actually appearing in. So, the information is used to reconstruct the protein based on modern organisms of the relevant species, otherwise known as the nodes. In the pictures displayed, that is the ways of starting a fire as an analogy. So at each node, there is an estimate made for each of the 20 amino acids at each residue site in a protein, predicting the likelihood that a particular site or residue occupied by a specific acid. Now, the recreating of the evolutionary history uses patterns in modern sequences, a matrix of the previously mentioned probabilities at each site. We got site-specific replacement rates, and the distance between phenotype nodes, and more to maximize the accuracy of the prediction. The most likely amino acids at each site form the reconstruction of the node, but comparisons are made based on phenotype, which is making fire, not the genotype or the specific amino acids. While there are opportunities for bias in the reconstruction process, researchers do take a lot of great strides to make sure that that doesn't affect things as much and result with a lot of hydrophobic residues, for example. Now, another use for this reconstruction is to determine what environmental factors actually resulted in the proteins that we see today. So in the example before us, why did a lighter upgrade to a flamethrower? Well, people decided that while setting things on fire was nice, they needed to set things on fire that were far away. So the appropriate evolution occurred, and we have flamethrowers. Now, okay, so as a much more reasonable example, let's say you have a protein that you need to function in a high oxygen environment, and the one you currently have functions in a moderate or low oxygen environment that's more realistic to what we have today. You also know that your protein comes from a fern, which is a biological family tree that you're actually rather familiar with because you pay attention in your other classes. Now, you also know that in the prehistoric world, the oxygen content of the atmosphere was significantly higher than it is today. So, what you get as an idea is to reconstruct proteins backwards through the evolutionary tree towards a protein that may have better function in the high oxygen environment than what you currently have today. I hope this high level overview of ancestral protein reconstruction was helpful, and good luck on the exam.